Chapter 11, Section 5 in the 8th grade note-taking guide is entitled Solving Multi-Step Inequalities here. So we're continuing on our route here of solving inequalities as we did in 11.4. These just happen to be multi-step. So as far as some of the things we saw yesterday, that little trick rule about multiplying or dividing by a negative that we already knew, yes, you're going to see that here. As far as graphing here, yes, you could end up graphing here. The graphing technique would be the exact same thing, though, as the graphing technique you saw yesterday. So there's nothing new there. All that's new about this, if there's anything new to be said about it, is that it's multi-step. So we're going to solve these like we solve multi-step equations. Again, all those rules that I've already taught you for equations continue to apply here as far as me working with inequalities. Variables on the left, numbers on the right. We know that. We've seen that. We've done that. That's all that's going on here is me using those same rules here to solve these inequalities. All right, so as far as me solving, let's get going here. 4x plus 1 is greater than 13. So we know the rules say to keep the variables on the left and numbers to the right. So that means we like the location of x because it's a variable and it's on the left side of the inequality sign. We also like the location of the 13 because that's a number and it's on the right side of the equal sign. That means we don't like the 4 and the 1. So both of those are going to have to move here. Now as far as moving the 4 and the 1 go, we remember that the thing that's directly connected to the variable goes last. That's a rule we use for equations, and it's the same rule we use for inequalities because remember, they're solved the same way here. So I'm going to go ahead and start solving that off here by subtracting 1 from both sides. Since 4 is going last, that means 1 is going first. And I subtract 1 from both sides, and I end up with 4x is greater than or equal to 12. Well, now it's a very basic one-step inequality, a multiplication inequality, no less. So, of course, that means we're going to solve this by dividing at this point. We, of course, want to get that variable all by itself on the left side of the equal sign. Again, all these numbers have to go over to the right, so that means the 4 has also got to fly at this time. Again, we do the opposite to move something to the opposite side of the inequality sign. So since this is saying multiplying right now, the opposite is going to be to divide. And when I do that division, 12 divided by 4 is, of course, going to change into 3. So we're going to end up here in this particular question with x is greater than or equal to 3. They're also asking us to graph x is greater than 3 here. So that's an open dot on 3. And my shading is, of course, going to take me to the right. And again, that's nothing new than what we saw yesterday. Part B, 2 times x plus 4, in parentheses, minus 11x greater than or equal to 26. So that's a distributive property question because we have a number in front of a set of parentheses. That's always an indicator of the distributive property. Distributive property says we take that number and we multiply it through to simplify. So I'm going to take the 2 through to the x and 2 through to the 4 to write a simplified statement here. 2 through to the x gives me 2x, 2 through to the 4 gives me 8. So I've got 2x plus 8 minus 11x is greater than or equal to 26. Now you've got some options here. You could at this point start sending numbers to the right side of the inequality sign. That's an option. Your other option is to go ahead and just start combining like terms and simplifying and then send things to the right side. And that's exactly the route that they've decided to do here. So they've decided to go ahead and combine the 2x and the 11x at this time. 2x minus 11x is going to give me negative 9x. So I've got negative 9x plus 8 is greater than or equal to 26. Now if you're sitting there going, well wait, why didn't you do the opposite? Isn't it time to do that? No, it's not. And the reason it's not is because I never moved anything to the opposite side of the equal sign. They stayed on the left side. They were both on the left. When I combine them, it's still on the left. I've never had to do that step because I didn't move anything to the opposite side. But I will in just a moment. I've got negative 9x plus 8 is greater than or equal to 26 now. Variables on the left, numbers on the right. So the 9's got to move and the 8's got to move. But we know that the thing that's with the variable goes last. So since the 9 is with the variable, that's going to go last, which means 8 is going to go right now. remember, when I want to move something to the opposite side of the inequality sign, I do the opposite. So since 8's got an addition sign in front of it, that means I'm going to subtract 8 from both sides. So I've got 26 minus 8 there. 26 minus 8 is going to change into 18. So I've got negative 9x is greater than or equal to 18. All right, so one last step to go here because this is a very basic one-step inequality at this point. I'm going to go ahead and divide by negative 9 because, again, I just want to have that variable all by himself on the left side. Moving the negative 9 requires me to do the opposite, and this says right now that I'm multiplying by negative 9. So I'm going to divide across by negative 9 here. And because I'm dividing by negative, that's where I have to use that one little trick rule. That trick rule says when I multiply or divide by a negative, it flips the direction of the inequality sign. So it's not going to be greater than or equal to in my solution anymore. It's going to be less than or equal to. And that's what I have to fill in the blank here, less than or equal to. So we end up with x is less than or equal to negative 2. That's me placing a closed dot on negative 2. And my shading taking me to the left. Same way the inequality sign points is the way the shading occurs. The numbers that are less than negative 2 are negative 3, negative 4, negative 5, negative 6. That happens to be in the region I shaded. Now here's a fraction question. 2x plus 5, or 2x over 5, plus 3 over 4 is greater than or equal to 9 over 10. So as you recall from when we did the section that involved equations with fractions, the approach was to get a common denominator. Well, since we do these questions the same way, my approach is going to be to get a common denominator. So that's where I need to start here. If I look at the denominators I have in this question, I have 5, 4, and 10. Well, the common denominator of 5, 4, and 10 hits at 20. 5, 10, 15, 20, 4, 8, 12, 16, 20, 10, 20. The match is at 20. I did the least common multiple of 5, 4, and 10 and found that the match is at 20. So the least common denominator is 20. So that means I'm going to rewrite this problem so all those parts have a fraction where the denominator is 20. Well, let's start on the right side and work backwards. To change 10 into 20, we're multiplying by 2. So I'm going to multiply the top by 2 as well. That's going to give me 18. To change 4 into 20, I'm going to multiply by 5. So I multiply the top by 5 as well. 3 times 5 is 15. To change 5 into 20, we multiply by 4. So I multiply the top by 4 as well, and that's going to give me 8x. Now, once you have a common denominator, as you recall, what you do now is you multiply the entire line by said denominator. So since the bottom number is 20 here, I'm going to go ahead and multiply by 20. What's going to happen there then is I'm going to cancel that denominator out with this number I'm multiplying by, meaning I have a problem now with no fractions. I have 8x plus 15 is greater than or equal to 18. It is possible the fraction might come back when I'm done, but that's okay. Even if the fraction comes back when I'm done, I'm just going to leave it a fraction. It's not going to have an impact on me if there's a fractional answer. All right, so let's use the rules of solving inequalities to solve this inequality. 8x plus 15 is greater than or equal to 18. Keep the variables on the left and send the numbers to the right. So we see the two troublemakers here for us are 8 and 15. I need to move both 8 and 15. Remember, the thing that's directly connected to the variable always goes last. So since 8 is directly connected to x, that's going to be the last thing I move, which means 15 is going now. Remember, when I move something to the opposite side of the inequality sign, I do the opposite. So since 15 has an addition sign in front of it, I'm going to do the opposite, which is to subtract. So I'm subtracting 15 from both sides, and I have 8x is greater than or equal to 3. And now this is a multiplication problem, and of course if I'm solving by doing the opposite, that means I'm dividing. So I'm dividing across by 8. When I divide across by 8 here, 3 divided by 8 is going to be my solution. Again, it's okay that that's a fractional answer. I'm going to leave it exactly that. Why do an extra step of changing this into a decimal equivalent? There's nothing wrong with saying x is greater than or equal to 3/8. All right, number 3. A school's Spanish club is selling bumper stickers. They bought 100 for $55 and have to give the company 15 cents for every sticker they sell. If they plan to sell each bumper sticker for $1.25, how many do they have to sell to make a profit? So this is not unlike a question we had yesterday. What we figure out first is what our actual profit is. Well, if we're selling the bumper stickers for $1.25, but we have to give back 15 cents for every one we sell, then our profit equates to $1.10. So to find what I'm going to make on each bumper sticker, I'm going to multiply together $1.10 and x. X is how many I sell. Right now, that's an unknown, hence the reason it's a variable, because a variable represents what we do not know. Now, what the question says here is that they have to at least make back what they spent in order to make a profit. So that's $55. So that means in order to make some money here, I've got to make that $1.10x exceed 55, which is why they're saying it's got to be greater than 55. Well, so now we're going to solve that really simple multiplication inequality. That's easy because we all know how to do that. We do the opposite, just like we've done every single problem here with the inequalities. I'm going to divide out the $1.10 on both sides, and when I take the 55 and divide by $1.10, 55 divided by $1.10 changes into 50. So the Spanish club has to sell more than 50 bumper stickers in order to make a profit. You can use your calculator to check if I sell exactly 50 times $1.10, exactly 50 turns me $55. Well, that's okay, but the question says it's about me making a profit. Profit means I have to exceed what I spent. If I sell exactly 50 bumper stickers, it's a wash. I haven't made any money, I haven't lost any money, but I haven't made any money either. But once I cross over the 50 mark, then I'm making money. All right, so let's look at the concluding examples here. Number 1, solve and graph negative 4x plus 2 is greater than or equal to 18. So the two things we know that we like about this question are the x and the 18, because we know we like that variable on the left and we know we like that number on the right. We don't like the 4, we don't like the 2, because those are numbers, they belong on the right side with 18. So we know that the thing that's directly connected to the variable goes last. 4 being connected to the variable x means it's going last, along with this negative sign. All right, that means 2 is going first. That means 2 is going now. Again, when I'm moving things to the opposite side of the equal sign, I do the opposite. So since 2 has an addition sign in front of it, that means I'm going to subtract 2 all the way across, and I end up with negative 4x is greater than or equal to 16. Now that's a multiplication inequality. That's going to be solved by dividing here. And of course, at this point, it'd be for me to divide by negative 4. We knew we had to move negative 4 because we said just a minute ago that that was the other thing we didn't like here. So as far as me dividing here, I've got 16 divided by negative 4, which is going to change into negative 4. So I've got x and negative 4. Now, I've hesitated writing the sign, though, because we did divide by a negative here. As you know, when we divide by a negative or multiply by a negative, it flips the direction of the inequality sign. So what I don't want to do is I don't want to write greater than or equal to back in. I want to write less than or equal to. X is less than or equal to negative 4. All right, now the question also asked me to graph, so we'll make ourselves a quick little graph here. The dot on this number line here is going to go at -4, and because it's one of the ones that has the line underneath, it's going to be a closed dot, and then we're going to shade accordingly. The shading is going to take me to the left, and the reason it takes me to the left is because this sign points to the left. And again, that only works when we write the variable on the left side, but I've trained you for 2 years to put that variable on the left side, so hopefully that's what you're doing. The inequality graph says the same thing the statement says. The numbers that are less than or equal to -4. Well, the numbers that are less than -4 are numbers like -5 and -6 and -7 and -8 and -9 and -10, which is exactly what shading to the left would highlight. Number 2, 3x over 5 plus 1 over 4 is greater than or equal to 5 over 10. All right, so as far as me working this question out here, again, I'm going to be thinking about a common denominator as we did in the fraction question earlier. Well, these actually happen to have the same denominators, 5, 4, and 10. The common denominator is at 20. So I'm going to go ahead and write this question with common denominators on each fractional term of 20. Even if they weren't fraction terms, I'd still have to write them with a common denominator of 20. But these are all fractions, so I don't really have to think too hard about that. I'll start from the right side again. To change 10 into 20 means we're multiplying by 2, so I'm going to multiply the top by 2 as well. That's going to give me 10. To change 4 into 20 means I'm multiplying by 5, so I'm going to multiply the top by 5 as well, 5 over 20. To change 5 into 20, I'm multiplying by 4. To change 3 then, I'm multiplying it by 4, and it becomes 12x. Since my common denominator is 20, I'm going to go ahead and multiply the whole line by 20. When I multiply the whole line by 20, that cancels it out with all my denominators, and I'm left with 12x plus 5 is greater than or equal to 10. All right, so let's solve now. We know what we like about this inequality. We like the placement of x, variables on the left. We like the placement of 10, numbers on the right. What we don't like then are the 12 and the 5, because those are numbers that eventually have to get kicked over to the right side of the inequality sign. But we know that the thing that's with the variable goes last. I mean, 12 is going to move last, which means 5 is going to move first. So let's go ahead and kick the 5 out of the way here. So, me doing the opposite. Again, the rule is opposite side do the opposite. So I've got 12x is greater than or equal to 5. And then I'm going to solve this multiplication inequality by dividing here. Dividing across by 12. And that's going to give me x is greater than or equal to 5 over 12. All right, now the question says for me to graph, so I'm going to sketch myself a quick little graph here. Dot goes on the number that's in my inequality, which happens to be 5/12. It's a closed dot because it's one of the ones that has the line underneath it. And then since my sign points to the right, I shade from my dot to the right. Numbers like 1 and 2 and 3 are the numbers that are bigger than 5/12, and that's exactly what the shading covers. Numbers like 1, 2, and 3. All right, let's look at the wrap-up question here. The French Club is selling drama tickets. They have already sold $1306.50 in tickets. Their goal is to sell enough to make revenue of more than $2,340. If each ticket is sold for $9.75, how many more tickets do they have to sell to reach their goal? All right, so what we know here is that each ticket generates $9.75. So in other words, the money they're generating can be written by writing 9.75 times x. 9.75 times the number of tickets they sell. Now, what the question says is they're trying to make $23.40, but they've already sold $1306.50. So all we have to do is figure out how much more they need in terms of ticket numbers to reach their goal. So if we do a quick little bit of subtraction there, $23.40 minus the $1306.50 they've already sold means to reach their goal, they only need to sell $1,033.50 more. So 975x has to exceed $1,033.50 now to figure out how many more tickets they need to reach their goal. Well, this is a really simple one-step multiplication inequality. If it's multiplication, that means we're going to solve by dividing. So I'm going to go ahead and divide all the way across by 9.75. When I take that 1,033.50 and divide by 9.75, the result turns out to be 106, which, put back in context, means they need to sell more than 106 tickets to reach their goal.